Hello, welcome to Unit 4. In this unit, we're going to talk about relationships within triangles. Specifically, we're going to talk about how to classify triangles by their sides, by their angles. We're also going to talk about how to find angle measures using properties of triangles with interior and exterior angles. Okay, so let's go ahead and jump straight into it. Okay, in this first video, we're going to talk about classifying triangles by their sides and angles, as well as the triangle angle sum theorem. So by the end of this lesson, what we're going to be able to do here is find a missing angle for any triangle. And also, we're going to be able to determine missing angles and sides if we know that a triangle is an isosceles triangle. So I'm going to be switching back and forth between this PowerPoint and this slide here. This slide has more information that we're going to take a look at, more examples and stuff. And this PowerPoint doesn't have as much, but I will post the PowerPoint in any case. It does have a nice graphic organizer that you can access online. And when we zoom in, you can see that it gives you all the types of properties of triangles and also gives you some of the descriptions of them. But in any case, let's come back over here and let's start with our notes. Okay, so all of these notes, acute triangles, obtuse, equilateral, so on and so forth, all of these have text boxes already in place for you to click on and type in, so you don't have to make any of that yourself. And the examples, these will have text boxes as well. So that way you can type into them and make sure that you're getting all of your notes. So I'm going to go here into present mode, and we're just doing this so that way we can view these slides a little bit easier. So let's go ahead and start with classifying triangles by angles. This is probably going to be the easiest out of the bunch, just because with angles, there's only a few things that we're looking for. The things that you're going to need to know before you actually start this unit, you're going to need to know what an acute angle is, what an obtuse angle is, a right angle is, and also what the word congruent means. If you don't know these three things, then you're going to want to go back and review them before getting to this point. Okay, so we're just going to work our way from left to right. If you have three acute angles, that's going to be an acute triangle. So that's how you would classify a triangle by three acute angles. It's just an acute triangle. Okay, real easy, real simple to remember. Now, with acute triangles, there's a very special kind of acute triangles, and that is in the case where all three angles in the triangle are congruent. So what that looks like is all angles are 60 degrees. Okay, this is a very special case of classifying triangles by their angles, and it's a very special case of acute triangles. Okay, so when you see a triangle that has either these three arc marks in all the angles, okay, that means that all the angles are going to be 60 degrees. Okay, and we call this one an equiangular triangle. So equiangular. Equiangular triangle. And this word just means that all of the angles, that's angular, all of the angles are equal. So equiangular, equal angles. Okay, so this is a special kind of acute triangle. So I'm just going to put that as a little side note for us. Special kind of acute. There we go. Okay, we know what right angle or a right angle triangle is. It's just a right triangle. And what's special about this one is that one angle is 90 degrees. Okay, one angle is 90 degrees. Now, if you have, let's say that angle 1 and angle 2 here, okay, let's say that they don't give you this 90 degrees, but they give you these two angle measures, okay, and angle 1 and angle 2 are complementary. So they add up to 90 degrees. Then we know that this entire triangle is going to be a right triangle because in triangles, all of the angles add up to 180 degrees. Okay, so with right triangles, the two angles that are not the 90 degrees are complementary. Okay, the last one that we have is an obtuse triangle, and that's when you have one angle that is obtuse. Okay, so acute, obtuse, right, and equiangular. Those are the three or the four kinds of classifications by angles for triangles. Now let's come down here and take a look at this diagram and answer some of these questions. We're going to classify each one of these triangles by its angles. Okay, so this first triangle, triangle CDE, I'm going to outline in blue. So we have C, D, and E. So we're making this triangle based on the angles that they give to us. Okay, so we notice here that in this corner, we have this 90-degree angle. Okay, so the 90-degree angle goes from CE and then D. So this one's going to be a right triangle. Okay, the second one, BCE. We'll do this one in red. So we have B, C, and E. Now this one's a little difficult to classify just because we don't have any angle measures, but you can just tell that right here, this guy, this angle in red, is going to be bigger than 90 degrees. Okay, so if it's bigger than 90 but less than 180, that is an obtuse angle. So in this case, we have an obtuse triangle. Okay, number 3, ABE. ABE. Okay, ABE has the 3 congruent marks, like up here in this picture. Okay, so this one is going to be equiangular. Now with equiangular, you do not need to write that it is also acute. It's just implied that if you have equiangular, that it's also going to be acute. So you don't need to double dip on that. Just putting equiangular is fine. Number 4, triangle BDE. I'm going to choose a different color. I'm going to do this pink color here. So B to D to E, back to B. Okay, we already know that this is 90. So if we add a little bit more on this angle here, the CDE angle, then that's going to be obtuse. So another obtuse triangle. And the last one, we'll just do this one in black, CFE, C to F to E. Okay, we know that this one was 90, right? So when we take away from it, it's going to be acute. This is a linear pair. This is going to be acute. So this one is also going to be acute. So we have 3 acute angles, acute triangle. Now my corny little way to remember some of these, acute is a acute triangle, literally 2 words, a cute triangle. So when we tend to think of cute things, a cute dog is typically a tiny dog or a small dog, or when we think of cute people, babies are cute, right? Babies are small. So acute triangles go with the smallest angles, which are acute angles. Obtuse triangles are larger, and then the right triangles, 90 degrees. Okay, now when we classify triangles by sides, this has nothing to do with the angles that we see. It only has to do with the sides. So when you do it by sides, what you're really looking for are the arc marks. So here with the 3 congruent sides, okay, you're looking for either 3 arc marks or 3 angle measure, or not angle measures, 3 side length measures that are the same length. So 3 congruent sides is going to be kind of like the 3 congruent angles, except that with the 3 congruent sides, we have equilateral. So lateral is our word for sides, so equilateral for 3 congruent sides. Now 2 congruent sides, this one is kind of like, we don't have one that's similar, but 2 congruent sides, this one is isosceles, and it's very special because isosceles, we can determine a few things about the angles by the sides. So with isosceles triangles, when we know that we have 2 sides that are exactly the same, okay, then we can say that the angles that are opposite, so if I drew a line from this side here and I went to the opposite angle, okay, this angle is facing this side, okay, that's going to be one of our base angles, and the other base angle is going to be across from the other side that is the same length, right? So from here we have isosceles, 2 sides are congruent, and the angles that are across from the sides that are congruent, we call those the base angles. So I'm going to make a little mark of that down here, and we need to know this because some of the questions that we're going to be asked, they're going to tell us what the base angles are, like the measures of it. And they may ask us to find the vertex. So the vertex is just going to be the peak point of this triangle. So here's the vertex. So sometimes what they do is they give us this angle measure here, and then they say that it's an isosceles triangle, and they want you to find the base angles. So we'll take a look at a few examples that incorporate this in just a second. Now, if there's no congruent sides, this one is called a scalene triangle, scalene. So scalene has no congruent sides, and we can't do anything with angles with it. So let's classify some of these triangles by their sides. We have 6, 7, and 8 down here to take a look at. First one is JKM. So J to K, and then from K to M. So when you're classifying triangles by sides, again, what you're doing is you're looking for the hash marks. Okay, the hash marks are going to tell you a lot about the picture. Now, notice that J to K has 1 hash mark, and then J to N has 1 hash mark. So we know that JK is not going to be the same length as JM or KM. So we can't do anything with this one. We also don't know anything about LM or NM. So just based on this assumption, since there's no angle links, we cannot determine if there are any congruent sides. So this one's going to be scalene because they didn't tell us these pieces of information, and we can't determine if they are congruent because there's no angle measure. So this one's going to be scalene. We're going to assume that there's no congruent sides. Number 7, KLN. Go K, L, N, and then back to K. Okay, so it's just a green triangle here. We have 2 hash marks from K to L, and we have 2 hash marks from L to N. So that tells us right away that we have two congruent sides. K to N only has one hash mark. So it's not going to be congruent to KL or LN. So this one's going to be isosceles. Okay, so we have an isosceles triangle. And our last example, we'll do this one in purple, JKN, J to K, K to N, N to J. All three of these sides have one hash mark, so that's going to be equilateral. Okay, now down here at the bottom, it says to classify each one of the triangles by angles and sides. Okay, so we're doing two different things. You should have an answer from up here with the angles and then an answer from one of these three with the sides. So we'll just take a look at a few of these. We won't do them all. But we'll start with number 9. So number 9, the first thing that I notice in this one is that it has a right angle. So the first thing I write down is right, because it's a right triangle based on the angles. And then based on the sides, okay, there's two sides that are the same length. So I come over here, that's going to be isosceles. So we have a right isosceles triangle. Okay, you should never have two descriptions from the same category. So there should never be two descriptions based on the sides. There should never be two descriptions based on the angles. Number 11 here, okay, I'm going to skip over 10 so I have some more room to write. Number 11, if we take a look at the three sides, okay, this one is 7, this one's 7, and this one down here is 7. So based on the sides, this is an equilateral. Okay, again, notice what I said. I said based on the sides, not the angles. It's equilateral. And then we come down to the inside of the triangle. Okay, this one's 60. We have 60 again, and then 60 again. So we have three angles that are the same. So it's also going to be equiangular. We have equilateral and equiangular for number 11. Okay, so that's just the gist of how to do some of these. I'm not going to do any more from this page because we need to move on to some of these other things and talk about them very quickly. So this entire first slide is taken care of. Make sure that you go in and you type your definitions into each one of the text boxes. What we're going to take a look now, or we're going to take a look at now is the triangle sum theorem, equiangular triangles, and then right triangles. But our main focus here is going to be the triangle sum theorem. And then the last slide, what we'll do is we'll take a look at 3 more examples and how to solve for the angle measures given these things. Okay, so let's come back here to, let's see if we got anything good here. Yeah, I don't think there's anything else that we need to cover in here. Missing angle practice. Yeah, so we'll come back here real quick. All right, now the triangle sum theorem, all it's saying is that for every triangle, the sum of the angle measures is going to be 180 degrees. Okay, this is for every triangle. It doesn't matter what it is based on its sides, based on its angles. Every triangle, the sum of the angle measures is going to be 180 degrees. So here's the formula for it. All you're doing is you're just adding the 3 angles together. Okay, that's what this first piece is. And then you set it equal to 180. Okay, pretty straightforward, real simple. Sometimes to find some of these missing angle measures, you'll have to know things like vertical pairs, linear pairs, stuff like that. But what we'll do is we'll take a look at a few examples here in a second. Equiangular triangles, we've already talked about these. Again, all 3 of the angles in equiangular triangles are going to be 60 degrees. And then with right triangles, This is just a reminder, okay, right triangles, the acute angles, or the two angles that are not 90 degrees, the acute angles will be complementary. So if you add them together, they equal 90 degrees. Okay, so here's a few examples. Let's go ahead and work this first one, and we'll do this one in red. Okay. Red. Okay, we're going to classify this based on just the angles, right? So only the angles are given, not the sides. So when we classify this, okay, remember what we're looking for. We're looking for one of the 4 definitions that we had. In this case, we have the right angle. So this one's going to be a right triangle. Now for solving for x, okay, remember what we said about this definition. We said that with right triangles, the acute angles are complementary. All right, the acute angles are complementary. Complementary, we add to 90. So what I'm going to do is I'm going to take 65 and the x. I'm going to add them together. X plus 65. And I'm going to set it equal to 90 degrees. All right, that's what complementary means. So in this case, our x is equal to 25. Make sure that you include your degree symbol, 25 degrees. Okay, the second one, this one right here, they give us 2 different things, right? They give us this x, they give us the 53, they give us the y. But the most important thing here are these hash marks. Okay, so the hash marks go with the sides. And this one, with 2 congruent sides, we know that this is isosceles. Okay, so we talked about this, about the angles with the isosceles back on the previous slide. But what I'm going to do here is I'll write it down and spell it out for you. So once we do that, we'll come back and we'll talk about the 53 and the y and what that means for us. All right, so what we said was that if we have an isosceles triangle, then the base angles of the isosceles triangle are going to be congruent. Okay, so the base angles are across from the sides that are congruent. So we have one side that's congruent here. So that means that the 53 is going to be the same as this y, because the y is across from this side that's congruent. So we can go ahead and fill in that y is going to be 53 degrees. Okay, that's probably something else that we need to write down. So let's go ahead and do that real quick, and then we will talk about angle x. All right, so there we go. The base angles are across from the congruent sides. Okay, so now that we figured out what this angle y is, okay, our last thing to do is figure out what x is. So anytime that you know 2 angles of a triangle, okay, you can find the third missing angle by using the triangle sum theorem. Okay, so here's our little note for it. Anytime that you have 2 angles in a triangle, you can find the missing angle by using the triangle angle sum theorem. Okay, so for this problem, okay, what I'm going to do is I'm going to say angle 1 plus angle 2 plus angle 3 is equal to 180, right? That's what the triangle sum angle theorem, triangle angle sum theorem says. And then we know that one of our angles is 53. We have another one that's 53. And then the missing one is just x. So this is what I get when I plug in what I know to the formula. 53 plus 53 is 106. X doesn't change, and neither does the 180. Get the x by itself, we subtract 106 on both sides, And then that gives us 74 degrees. Right, so we already classified this triangle by its side, right, because of the congruent hash marks. Now we can go back and we can classify it also by the angles, right, by the angles. So if we did that, what we would be looking at, back to our slide real quick, we'd be looking at this one right here because it has 3 acute angles, right? All of our angles are less than 90 degrees. So this one is going to be acute. So we have an isosceles acute triangle. Okay, number 9 down here, it's very similar to what we did in number 5, like in terms of solving for the missing angle. So what we're going to do here is, number 1, we need to come up with the formula, right? So we know that we have a right triangle because of the 90-degree angle. So with right triangles, the 2 acute angles are going to be complementary. So my 65 plus 6x plus 1 is equal to 90. 65 plus 6x plus 1 equals 90. Let's combine all the like terms. That's going to be the 65 and the 1 on the left side, which makes 66. We have 66 plus 6x equals 90. Take away 66 on both sides, and that leaves us with 6x equals 24. So x is equal to 4, which is what we needed. Okay, so we can't classify this one by the sides because there's nothing given to us by the sides. So the only classification that we can give here is the right triangle. So what we're going to do now is we are going to stop this video, and in another video I will have some more examples completed, so that way we can go back and get more practice and possibly answer some questions. Okay, so be on the lookout for that video. And the next topic that we're going to take a look at are inequalities in triangles, and specifically we're going to take a look at more triangle sum theorem, but the new stuff is going to be the third angle theorem, the exterior angle theorem, and then we're also going to come back and take a look at more right triangles and equiangular triangles. So we'll see y'all in the next one.